Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews and on-site training. Now, in this episode, I'm going to pick up where I last left off on that code review that I was doing of my own old code. Now, if you didn't see that episode, I do recommend that you watch it. It was, well, painful. This was my university code from 1998. We're going to pretend like this is real production code, and this is based on all of the plethora of comments that you all left. And we're going to pick up and say, now, what would I do if I actually had to maintain this old legacy code and I wanted to make it better? But there's a twist here. I'm going to pretend like we're still stuck in 1998 when this code was originally written, and we're going to start by using compilers from then. Now, I have created this project on GitHub, and it's in my best practices organization, which I didn't do on purpose, but you know what? I decided, yeah, sure, why not? I'm going to go ahead and keep it in the best practices organization, and we're going to make it something of an example of a real project. Right now, it is not a good project. Now, I created this using my CMake template, and there we go. All right, so it went ahead and renamed things like it was supposed to. We are just a moment behind here on looking at this. So right now I have this folder that's not part of the build process, but this is the original code with the Visual Studio projects. And we're going to start from here, but we're going to use this CMake project as a framework that we can eventually move this into something that has CI and all the things. Now, it turns out that Visual C 6 pretty much works on Windows 10. So let's go ahead and try to open that workspace, which I have not yet done. Now let's go ahead and take a quick look at this. So this is Visual Studio 6. I could not get Service Pack 3 to install. I think this means this is the original version of Visual Studio 6, but I'm not 100% sure. Now I want to make sure that I have the appropriate historical context here. Visual Studio 6.0 in September of 1998. Okay, so I just double checked, and this project was fall semester of 1998. So that is correct. Visual Studio 6 would have just been released, and in fact, I even have the CDs for Visual Studio 6 still from when I got those in university. Now let's see if this thing runs. Now the debugger won't let me single step on Windows 10 with this compiler from 1998, but I did prove that things like Hello World work. So let's hope that this builds. Look, I built and linked with no problem at all. If only all of our programs were that fast. Go. Oh, there we go. Hey, look, 44 plus 5 is 49, in fact. 3 plus 3 is 6, times 2 is 12. Okay. 126 plus 3 is 129. It appears to be working, so yay, the code does actually work. So this is a great starting point. We have the legacy code. It does its job. It gets the right output. Why do we want to change anything? Now, if you watched that last episode, you saw that I am passing pointers literally everywhere. This thing is absolutely just overflowing with memory leaks. It's things that I should be using the stack for, but we can't actually change any of this stuff until we add test. So let's kill this. All right, so we're gonna start with a test file. It does look like it is relatively testable. So let's go ahead and get a start here. Okay, so I have a tester, and I've righted some of the wrongs already by not using the heap unnecessarily. I need to add some other way of running the test. I can't have two different mains in this project. That's silly. All right, we're gonna reorganize this into a library as well. Hey, at least my warnings are turned up pretty well. Okay, the library compiled. But we can't link our executable because we have this unresolved external symbol. And I never used libraries at all back in the day here, so this is a little bit of a learning experience. Okay, so that's showing the proper dependency set now. Okay, and we're able to build and link. So const car to car is a problem. Now I want to start thinking about this as const character pointer, but I don't yet want to actually change the implementation. So we're going to see what happens if I do a const cast here. Now it highlighted it, so it looks like this version of C++, even though it's just barely when C++ got its first standardization, does in fact actually have const cast. I just realized I don't have header guards around any of these things. So I moved the file between projects, but it didn't actually move its physical location. So the evaluator, HPP and CBP, are in the wrong folders. We're just gonna manually move these things around. You know what? Let's put everything in the top level for right now. Null is an undeclared identifier. I got it compiling, I got it linking as a lib file. Let's see if we can build our test yet. We cannot. Evaluate expression is still an undeclared identifier. So I don't have the include guards, and therefore I have a problem. Now, this is an interesting point in this development. I am trying to make this code testable, and to make it testable, I'm gonna have to, I guess, change a few things, but I'm trying really hard to make these as minimal changes as possible. If you are personally in a situation that's this bad, then I might suggest that you start with something that can work outside of the project and just capture the output from executions. But I was trying to do a minimal set of changes possible to make this testable. Oh, evaluate expression. Oi. Warning, main should return a value. All right, so I got this test pass, but I also get a debug error. Damage after normal block. Now, I'm not 100% certain what that is about. Okay, so I've got some sort of heap corruption. Symbol this, not found. Free debug context. So it's in my string tokenizer destructor. Ha! That's hilarious, because with all of the memory leaks that I had before, I was never actually calling any of these destructors. That's just amazing. That's outstanding. So we found our first real bug pretty darn quickly. So let's go ahead and stop here. What I'm going to do is I'm going to commit this. The project is now testable. We did a little bit of re-architecting here in that we had to create a library and we added a new test project, and then we had to fix our include guards. So I think all told, it wasn't that big of a difference. And we discovered our first bug in the process. So this is step one. You need to make the project testable so that you can capture the current state of the system. The first thing that I need to note is when I left off, I had the problem that all of my Visual Studio project files, these DSPs and DSWs, had their line endings changed by Git. And that's a problem that you're likely to encounter if you have a similar situation. So to solve that problem, I had to update my Git attributes file to set the appropriate line endings for the legacy files in this project. Now, I'm not going to update any of these other things because I'm going to eventually move those files over into the main part of the project. And for review, I'm using this legacy folder to make sure that I kind of keep that code isolated while I get it testable. Now, I did get it testable, but we had a crash on the very first test. And I've spent some time thinking about this, and I realized what the problem is. The problem is that my destructors, this empty destructor here is completely unnecessary, and that just irritates me so badly that I did that to myself back then. But anyhow, we're not doing that yet. We're not doing any maintenance. We're making this code testable, and we're capturing the current state of the project. So the problem that we had is that the string tokenizer has this destructor, and I'm getting a crash in the destructor here. The problem is that I don't have a proper copy constructor. So I've added a destructor and I didn't follow what would have been the rule of 3 in 1998. So I'm getting a copy of this pointer, that is the string object, and I'm not able to actually copy the underlying data because I don't have a copy constructor. So I'm getting a double free on the string, and that's why I'm getting a crash in my test. So now we have a philosophical question. Do we update the tests so they still work as expected? Or do we continue down this road of just letting things work how they were working? I'm inclined towards doing this so that the code continues to compile and work, but we have all of the memory leaks. And then again, we're just trying to capture the state of the system. It's an interesting problem. I think I'm going to go down this road. Let's make a quick aside here. The things that I've heard for why I used the heap were: someone commented that back then the stack was too small. Yeah, but these objects are tiny. They're like 2 integer sized, so that's not right. And then someone else said, basically, that's just how we did it back then, but there was no reason to. I've got memory leaks everywhere. That's clearly not good. I think the actual reasons were I didn't understand copy constructors, so I was possibly getting that crash that I just encountered. I didn't use the standard library, and I could have. I could have used standard string. It definitely existed then. And I was learning Java also at that time and just didn't think about these things. And I think there's another big reason here. I don't recall the professors ever discussing memory leaks or efficiency. So let's go ahead and add a bunch more tests, though. So I'm still getting that crash, and I'm not sure why, actually. Okay, this is on a string tokenizer. It's destruction. That string tokenizer never should have been copied. So again, this comes back to this philosophical question of, do I try to debug that issue, or do I just go ahead and make the test work with the current state? It's a new character array, and I'm not calling the array destructor. I'm still getting a crash at the same place. So yeah, strcpy expects to copy the null terminated string in, including the null terminator. So is writing outside of the memory that had been allocated, maybe that's part of the problem. So let's give this another go. Okay, so I actually got past that error now. So that's a very minor fix. I think it was probably worth it. That code is clearly broken with undefined behavior. I have a lot more of that. But I'm still just in the effort of trying to get this thing testable, really. So fortunately here, I did get an actual crash, finally, in my test. So I know that I have a test that is perhaps not correct. My answers aren't wrong, but they aren't right either. All right, so we're trying to capture the state of the system. I really am just not sure how that 1 divided by 2 divided by 3 is correct. I don't think that it is. Let's make a note of that and then move on. So we have something like tests. We need to add a lot more. And we're trying to capture the current state of the situation, but I want to start doing these code modernization things that are really bothering me. So I'm going to do that in the next episode. The main thing that I want to fix right now, because I have gone ahead and captured the current state with a few tests, although I'm pretty sure this one is wrong and these things could definitely be better, but I've captured the current state. And I want to start making this better. And I'm going to do that by relying less on things like const cast and the heap. So let's just get to this. Now, it's entirely possible that for the sake of my computer science class, I wasn't allowed to use the standard library. But, well, I'm not writing this as computer science code anymore. I'm just pretending like it's very bad code. So I'm using a member initializer right here to initialize, well, the member. Please const the things. I'm sure there's some of you staring at this saying, oh my goodness, did you see how he missed the whatever thing? But I'll probably get to that thing, I hope, soon. Okay, so I think we can change our tests so that string tokenizer no longer needs to be passed as a pointer. Let's look at rational number and fix that one up. Rational number really never needed a destructor, and it really never needed to be created on the heap. The thing is 2 ints. That's all it is 2 ints. There was never a good reason for that. Now, my rule here is if someone passes me a pointer, then I have to check that pointer to see if it is valid memory. I know here it makes no sense at all to pass a pointer to the divide function and hope that what you get is a valid pointer. This just truly doesn't make sense. we just found this problem with const correctness. And let's go ahead and fix that. See, note all of this stuff is in a pretty much pre-standard compiler. It's a compiler that was released in 1998. So my stack object, this thing really bothers me. It uses void pointers and manual memory management that's just broken all over the place. So we have this thing called stack. It's a container adapter that's been here since the beginning. I'm just going to go ahead and make a template that uses a vector or something underneath here. Wait, whoa. Why am I creating a new integer on, no, it's just wrong. It's just wrong. There was never a good reason to have done that. Never a good reason at all. I'm going to stick by that one. Now see, this makes no sense. Not even kind of. I guess I'm pushing the pointers into the container, so that's why I did it. But that is a terrible, terrible reason. Calling pop back on an empty container results in undefined behavior. All right, so we know that we have now bugs that we've discovered in a couple of places. First of all, the manual grouping of 1 divided by 2 divided by 3 does give us the 1/6 that we would have expected. And the manual grouping of 1 plus 2 plus 3 plus 4 gives us the 10 that we would have expected. But we don't properly handle ungrouped, chained together infix values. So that's great. Now I feel pretty comfortable moving forward here and say we have discovered a whole new set of tests that need to be run, and we have discovered some bugs. All right, so I think the next thing that I want to do is look at the string tokenizer real quick. Size returns an int in this version of Visual Studio. Oh, it's painful. All right, the next one's kind of be a big one. Yes, I am doing operator overloading here. Okay, so this is interesting. That quick change that I just made actually broke everything. So that's a problem. It looks kind of obvious what happened here. It's in the divides. And I probably got the numerator and the denominator backward or something like that. So let's figure that out real quick. But this is why we have these tests before we start doing major refactoring things. Okay, there we go. We're getting the failure where we expected to still because we don't have any fix yet for the problem of ungrouped infix operations.